Hello students, this is our video on quantitative data analysis. We have so far seen all the components that you would need to start your research, all the way up to research methods. Once you've collected your data using your research methods and your data collection tools, then you need to analyze your data. So we have quantitative data and qualitative data. So we are going to begin with how do we on handling quantitative data, how we analyze it. So with quantitative data, we have some, it's a field that has been greatly researched, and you can find out quite a lot of reading material on quantitative data analysis. One of the things I'm going to try to do is avoid the big words that come with quantitative data analysis. One, I'm not an expert on quantitative data analysis. Two, it can be quite daunting, especially that we are doing pre-recorded videos to introduce this topic to you. So I'm going to avoid that. I'm going to try to make this as simple as I possibly can. Now, the most important thing you need to understand is that when we're doing analysis, we're trying to make meaning of the findings we've gotten from our participants, and we are trying to communicate something. So the simpler you make it, the better. Don't assume that the more complex you make it, that you're actually making things better for yourself as you're being marked. No. Your reader must understand what it is you're trying to communicate, the new information that you're bringing to light. So when we are doing quantitative data analysis, we're trying to make a numerical representation of what we have observed or what we have found in the field. So we're trying to describe or explain a particular phenomena from the quantitative data that we have collected. So first, we must prepare our data. Whether it's qualitative data or quantitative data, we must prepare the data before we begin to analyze it. How do we do that? Well, we start by editing. So here, once you've collected data through a survey, you may find there may be some inconsistencies in our responses. So take an example. You may have a respondent whom may not have answered the question if they are married, but went on ahead somewhere to say they've been married for 10 years. So that would be an edit. The person is actually married but just missed out that element. So you may want to edit some things where the respondent was inconsistent or didn't complete. But this is completable. There are some things that are not completable. Some responses which actually need the participant. And if that has been missed out, then that row of data needs to be taken out completely. Now we may have missing data. So maybe you've asked several questions, and a particular important element has been asked. Take an example. You may have asked you may have given questions on mobile phone usage, and maybe you talk about duration of usage, how many times somebody has used, if they do have a phone or not, and so on and so forth. If there's a particular question where you have about 10% of the people have eliminated answering that question, then it's better you take out that variable completely, because it's going to affect your results. So if you have certain missing data, that means on that you arrange your data according to columns. Each question is a column. Is this a question? Or it's a row. If it's question is a row or a column, whichever it is. If you have more than 10% that have missed out, then that whole column or that entire question should be eliminated. It shouldn't be part of your analysis. That's how we clean up our data. Those first two elements, editing and looking for missing data, that process is called cleaning up. So after that, we begin to arrange it. So one of the things we do, we code. There are certain questions, for example, you ask, are you male or female? Now, when you're carrying out your analysis, male is not quantifiable, neither is female. But what we can do is we can code. Male, you can turn male into 1 to mean 1 and female into mean 2. In other instances, you have what we call the Likert type scale, where you may ask somebody if they agree, disagree, do not agree, or something like that. So, of course, you cannot again quantify things like agree or disagree. So, you can decide to code that scale. Disagree from, let's say, from agree, highly agree, or sorry, say very much agree or just agree, and then there's neutral, then disagree and do not agree, maybe extremely, I don't know how I can put it, but to the latter end of the scale. So you can code that. So to very much agree, you can start with 1, going all the way to 5. 5 meaning I do not agree, completely do not agree. So that scale is also coded. There's there's also a situation where you may find one of those scales is unnecessary. For example, maybe it says extremely agree and agree. One may consider them the same and say, okay, let me just, for the sake of not to confuse myself too much, I may decide to combine those two. There is situations where you may have asked for a neutral and neutral really doesn't give you a response. We shall talk about that later. A neutral or do not know, it may not necessarily give you an answer, so you may decide to skip it out. Or in some situations, it's important for someone when they say I don't know or they are neutral about something. You may decide in that time whether you want to accept it or not. This is when we say we are transforming our data, coding and transforming our data. So I hope that one is clear. Two, the next thing after that, we need to consider variables in our analysis. So when we're analyzing quantitative data, we know we're dealing with variables automatically. So we have what we call a univariant, then we have bivariant and multivariant. So a univariant is where we ask a question and we're only dealing with one variable. So for example, when you ask somebody's age, their gender, or their income, that's a question that is dealing with one variable. Then you have questions that deal with two variables. So if we want a research question which is dealing with gender and CGPA, so we want to know a person's gender and their CGPA, or rather, let me put this in Ugandan terms, if you want to say their gender and their O-level qualification. The marks they got or something, the range in which they got their marks. Those are, we're comparing the gender and the grade they may have fallen into at their O or A level. So those are two variables. Then you have multiple variables. If you're looking at the participant's age, education level, and their prejudice to something, yeah, maybe prejudice, acceptance of ICT or something like that. So that's multiple. That's a multivariant analysis. Okay, so a univariant analysis is normally dealing with description. So if we are looking at the age of university students, so it's just a description to see the age groups that exist at university level, maybe at bachelor's level, at undergraduate level, or the age group that visits a hospital, a particular hospital. Maybe we are looking at that univariant analysis is simply for description or explanatory purposes. Now, in this univariant analysis, one may want to look at distribution, yeah, frequency distribution of something. For example, maybe how many 25-year-olds are in bachelor's, or how many 25-year-olds are doing masters, or something like that. So people in the age group of 25, you may want to do that cluster, giving that distribution of a particular age group. At a university level. Here we have an example which is showing religion and the frequency, how many Protestants are existing in a particular research group, how many are Catholics, how many are Jews, and how many maybe have no religion or have fallen in a particular religion. That is a distribution analysis. So here it can go further by providing the distribution analysis with a pie chart. So one can also do this maybe if they are doing research on ICT and maybe age groups, income groups or something like that. One may want to give that kind of distribution analysis. Then we have also providing a central tendency, which is the mean value. So here you may find an analysis which provides the mean, the mode, and the median. So an example would be if one is doing an age, they want to say which is the mean age of all our participants who have GPA or maybe have O-level certificate or A-level certificate, which is the mean age, or the mean age of university students at undergraduate level, at master's level, that kind of thing. So that is giving a central tendency. So analysis also with one variable could also look at dispersion. We want to see what's the highest value, what's the lowest value of something, the distance separating between something, what is the highest value or the lowest value. We can also look at variance, how many times something appears. So take an example, if we are doing IQ level of university students, if an IQ test is done, and then you have the different levels, maybe from 100 to 120, 160, and so on and so forth. Maybe let's say 160 is the highest. So how many times does 160 appear in a certain age group or certain group of university students? How many times does 100 appear? You may have 160, but it appears only twice, or 100 appears maybe 5 times, or you may have 100 and 160, but 160 appears more in a particular program. So that is dispersion when we're looking at variance, the variance level. Also, things like standard deviation is how many times the highest appears and how many times the lowest may appear or something like that. This is when we're looking at dispersion in data analysis. The other is when we're looking at continuous or discrete variable. Yeah, there are certain variables whose value changes. For example, your age doesn't change, may not change within a certain research, but your income can change. So that's a continuous variable. Then we have the discrete variables, like marital status, gender, things that don't necessarily change over time. In our analysis, we can also decide to do subgroups. So take an example. We are dealing with age. We may want to categorize our age groups and what they feel about an opinion on a particular thing. So here we have an example of a research which was done looking at legalizing of weed or marijuana. So you can decide to do categorization between different groups to see what the different groups felt about something. So you can also do that, for example, for ICT, adoption, open source, and so on and so forth. We also have what are referred to as collapsing responses, where we try to combine appropriate ranges. So even here, where someone may say agree, very much agree and disagree, we can decide to put those together, and then the disagree and extremely do not agree. those are grouped also together. Those are referred to as collapsing responses. You can decide to put them together because they more or less mean the same thing in an analysis. Now here we can also think about what the I don't knows or the neutrals may mean. You may include it in your questionnaire, but later on you realize maybe it doesn't really make sense. And what should I do with it? Should I exclude it completely? In other situations, it may be important when somebody says, I don't know. So take an example. If you have ICT students who are doing something online, using a system online, and you're trying to get their attitudes towards it, and someone says, I don't know, I am neutral about it. What does that mean? If someone says, I don't know, then they're actually using the system, they should have an opinion about it. So you may want to say, let me exclude it because it will actually affect my analysis. Let's look at how we may handle bivariant analysis in contrast to a univariant analysis. So in a bivariant analysis, this is where we may decide to create subgroups to analyze a bivariant analysis. So here we are looking, basically we are trying to determine the relationship between variables. So here we have an example of a research that was done looking at religious attendance in relation to gender. Yeah. Weekly church attendance or any other religion, those who go to church, even to a mosque, who are most frequent, either men or women. So now the previous showed that majority that were attending were women. So now in that analysis, someone can say they want to use a Charles Clarkson's comfort hypothesis, which says that women are treated as second class, and because they are denied gratification status, they decide to go to religion. Hence, more women attend church than women because they are second class. So that's just an example using a theory to come to a conclusion according to the previous research that was done. Percentages in a table. One of the things you do as you're carrying out quantitative research is present percentages. So how do we handle percentages in our analysis? So here we are going to look at a research that is looking at gender and attitudes towards equality for men and women. So in other words, so a group of people were given were surveyed to find out what were their attitudes towards equality for men and women, um, and to see who gives the most response. So here we have the results where we have one woman who was positive, one man who was negative, a woman who was negative, and then who are basically giving a positive attitude towards gender and equality. So the first things first is to separate the men and women, yeah, and group them. How many said positive, how many said negative. So based on that, it showed that 2% of women respondents were negative about it and 8% were, or 80%, so 20% were negative, 80% were positive. Then for the men, 60% were positive and 40% were negative. So based on that, it could be concluded that the majority, both men and women, favored gender equality, but you'd find it more amongst women than with men. So that is one way one can handle the percentage analysis. Then we come to the multivariant analysis. So where you have more than two variables that you are looking at. So we go back to the religion and attendance, where the research that was being done, you looked at those who were under 40, the men, how many attended church, and women, those who attended church. And therefore, one could make the conclusion that as much as you have less men attending church, we find that people, when men are over 40 and above, they do attend church a lot more than younger men. So here, this is where the grouping, the subgrouping comes in, and to give that analysis, to give a better picture of the analysis. So in conclusion, with qualitative quantitative data analysis, we classify our data, count, and then construct our statistical models based on that. It is better, the bigger the population, the more chances that we can generalize our data. I think I've mentioned this before, that the bigger your sample size, the better for you to generalize your findings. So here are just some references you can go to give you a better understanding of quantitative data analysis. So I thank you for listening to me, and we can post questions on our discussion forum.